Assalamu alaikum. In this lecture, we will discuss thermal expansion, Boussinesq approximation, Reynolds equation, Reynolds equation, and Prandtl mixing length theory. And the last lecture 9, we will discuss the Reynolds equation, turbulent flow with example, and Reynolds equation, how they will affected for the turbulence of the flow. Now we will discuss the thermal expansion. Thermal expansion, what is this? The change in the length is proportional to the length L. The change in the length delta L is proportional to the length L. The dependence of thermal expansion on temperature. The dependence of thermal expansion on temperature, substance and length is summarized in the equation delta is equal to alpha L delta T. इस लैमिनर थर्मल एक्सपेंशन बनती है ये, और यहाँ पर डेल्टा इज क्या है, चेंज इन लेंथ है, और डेल्टा टी चेंज इन टेम्परेचर है, अल्फा इज द कोएफिशिएंट ऑफ लीनियर एक्सपेंशन व्हिच वेरीज स्लाइटली विद द टेम्परेचर. The change in area due to thermal expansion can be written delta B is equal to 3 alpha P delta T, where delta B is the change in volume. Boussinesq approximation. What is Boussinesq approximation? According to the Boussinesq approximation, variation in density is neglected. Density everywhere is neglected except in the Boussinesq term in the flow field. You can say density will be neglected everywhere except one point, which is where is the point Boussinesq term in flow field. That is, there are flows in which the temperature varies little, therefore the density varies little, yet in which the Boussinesq drives the motion. It assumes that variation in density have no effect on the flow field except that they give rise to Boussinesq forces. In more practical example, for terms, this approximation is typically used to model liquid around room temperature, natural ventilation in buildings, or dense gas dispersion in industrial steps. Boussinesq approximation is a way to solve non-isothermal flow such as natural convection problem को solve करने के लिए हम Boussinesq approximation use करते हैं without having to solve for the full compressible formation of Navier-Stokes equation. Try to understand this point why we use the Boussinesq approximation. The Boussinesq approximation is a way to solve non-isothermal flow such as natural convection flow without having to solve for all the compressible flow formation of Navier-Stokes equation. We will use the Boussinesq approximation. The Boussinesq approximation was a popular method for solving non-isothermal flow. Navier-Stokes equation for solving the Boussinesq approximation. The Navier-Stokes equation governs the motion of fluids. In general, you can write for the compressible flow, that one is the Navier-Stokes equation. We use the fluid velocity, V is the fluid pressure, and rho is the fluid density, mu is the fluid dynamic viscosity, and G is the acceleration of the fluid. The Navier-Stokes equation are solved together with the continuity equation. The Boussinesq approximation states that the density variation is the only important in the Boussinesq term, rho G, and can be neglected in the rest of the motion. This yields in equation 3. Where the temperature, pressure have been replaced by the constant density, rho and rho naught for the body force, and other all for incompressible flow, and that one replace the magnitude 1 over rho delta dp over dt small respect to the velocity equation. The Navier-Stokes equation are solved together with that form of the continuity equation. The Boussinesq approximation that says that the variation is also generally assume that the viscosity mu is constant. अगर mu constant है तो equation according to equation 3 जो है वो हमारे पास reduce होकर इस फॉर्म में equation फॉर्म 4 की फॉर्म में आएगी. The Boussinesq term can be written. इस Boussinesq फॉर्म को हम कैसे लिख सकते हैं, रो नॉट प्लस डेल्टा रो is equal to minus rho naught beta T minus T naught G, where delta P is equal to rho minus rho naught. इक्वेशन 4 becomes हमारे पास क्या बन जाएगी, इक्वेशन 5 की डायरेक्टली बन जाएगी. इस इक्वेशन 5 को ब्राउन्सिक अप्रॉक्सीमेशन या टर्म को कैसे भी लिखा जा सकता है, वो क्या, डेल्टा रो G is equal to rho minus rho naught G is equal to rho naught P by beta T minus T naught G. यहाँ पर बेटा बेसिकली क्या है, थर्मल कोफिशिएंट थर्मल एक्सपेंशन है, और इक्वेशन 5 बिकम्स किस फॉर्म की बनेगी, वो ये फॉर्म होगी. यहाँ पर हम P को क्या लिख सकते हैं, P प्लस रो जी एच रो नॉट जी एच. Reynolds equation, Boussinesq Reynolds equation is a partial differential equation that describes the flow of a thin lubricant film between two surfaces. Reynolds equation is a partial differential equation which describes the flow of a thin lubricant film between two surfaces. It is derived from the Navier-Stokes equation and is the fundamental equation for the classical lubricant theory. The Reynolds equation is derived from Navier-Stokes equation. This equation describes the flow of a liquid in a rather detailed way. In doing so, he used a dimensionless number, Reynolds number. This number was derived to describe the transition form of laminar flow of a fluid or to a turbulent flow. However, plays a central role in the equation of Reynolds equation of lubrication. The equation how to draw the Reynolds equation. The classical Reynolds equation can be derived from the Navier-Stokes equation of the continuity assumption. According to the assumption, constant viscosity in Newtonian lubricant, thin film geometry, negligible body force, no slip condition. When these assumptions are applied, we obtain the following equations. The form of this. According to our assumption, we got that type of Navier-Stokes equation or continuity condition. Apply the boundary condition. It should be applied boundary condition with respect to u equal to 1 and w0 by 0. U is equal to u, w is equal to y is equal to h, where u1 and u2 represent the velocity varying surface evaluation of the integration constant leads to the continuity. There are 3 only equations for 4 unknown coefficients. Integrating the values, and we got the pressure. Now we will discuss the Prandtl maximum mixing length theory. Prandtl mixing theory is a two-dimensional model. Mixing length theory is a two-dimensional to describe the momentum transfer within a turbulent fluid flow. Mixing length is defined as the distance in the transfer equation, or simply it can be defined as the average distance, and the concept of mixing length is similar to the mean free path using kinetic number. The turbulent shear stress can also be calculated when the fluctuation component from UV are known, but since they are difficult to measure. Prandtl mixing length theory, which can measure turbulent shear stress in terms of measured quantity. There is a specification called the Prandtl mixing theory, and now you can derive the Prandtl equation with use of specific condition. The Reynolds stress हमारे पास यहाँ पर आ जाएगा. Thank you so much.